Hi, so today we are going to start a new lesson which is how to do matrix manipulation in Python. So we generally need matrices, and how do we define matrices in Python, do various operations with them. Everything is done with Numpy library, which is for Python, and it's very popular. And so in this video especially we'll be seeing how to initialize the matrices, how to initialize random matrices, how to define random numbers, and matrix addition, how to add the matrices, multiply the matrices in different ways, concatenate them in different ways, etc. So first let us see how to define matrices. So we have first of all we import the Numpy library and we give it an alias np, which is an alias for Numpy, which we have defined. We define now, and now I can call any function in this library with this command np.ones. This is a function which will give me a matrix of all with all the elements as 1. The size of this matrix is 3, 2 or 3 cross 2, as we can see here. This is a 3 cross 2 matrix with all the entries as 1. Second, another function is dot zeros, which obviously every entry is a 0, and the size is again 3 cross 2. Now I can say an identity matrix. If I want to define an identity matrix with 3 cross 3, a 3 cross 3 identity matrix, then I can use the function I, and it will give me an identity matrix with all the diagonal elements as 1s and off diagonal elements as 0. Then I can have let's say if I want to put some other entries on the diagonal, I can define with the function called diag, and all the entries I can mention here, and you can see all these entries along the diagonal, and the off diagonal elements are all 0. Next, let's say I want to define a random matrix. I can use this function and specify the size. This function will get me random numbers uniformly distributed between 0 and 1. So this will construct a 3 cross 2 matrix, as you can see here, a 3 cross 2 matrix with all the entries as uniformly distributed between 0 and 1. Then now a very useful operation in matrix manipulation is taking transpose of a matrix. So the rows become columns and the column becomes row. So you can see this is the matrix which is a transposition of the B matrix. Next, different ways of accessing individual elements in the in a matrix. Let's say this is the matrix 3 cross 2 matrix, as you can see here. It's a 3 cross 2 matrix B. I want to access 0, 0 element. So you know 0th, so this is the 0th row and this is the 0th column. I want to access this entry. Then I can simply specify B 0, 0, and this is what I get. Now I want to access row 1 but column 0. So this is row 1, and this is the column 0, and this is my entry which I'll be accessing. That's what you see here. Now in this way I can access any entry with this indexing which starts from 0, and Python gives me something special, which is I can access the last entry by indexing with -1. So when I say -1, this means the last row and this is the last column. So the last row and last column means this entry, So this entry can be accessed by saying b minus 1 comma minus 1. Now let us say if I want to extract entire row or entire column of b, what do I do? When I say this will extract the 0th row and all the entries in the columns, basically 0th row and every entry in that column, and that's what I get. You can see this is same as this one. uh, Now if I want to access a column, I say all the row elements of the first column, which means this is my first column, this is what I get, but in a vector format. This whole thing is vectorized, so it is a vector, so it is not a two-dimensional matrix. Okay, next, a very important operation in matrix manipulation is the addition. How do we do addition in Python in the Numpy library? So let us define two matrices A and B. In this way, you can see that size of A comma B, size of A is 2 cross 3 and size of B is 3 cross 2. Now I want to define a matrix C, which is the sum of C. I cannot add A and B, so I take A transpose, add it to B, and then scalar multiplication. So each element of B can be scaled simply by multiplying with 2. So I can say if I add A to 2 star B, so B is made twice and A is simply added to it. Next is matrix multiplication. We just now saw scalar multiplication with a matrix, that each element gets scaled by that scalar. But now let us see dot product. Dot product is the ordinary matrix multiplication. So we remember A was 2 comma 3 and B was 3 comma 2. If I take a matrix multiplication, this is what I get. Simply define it with A dot dot. So this dot operator does the dot product. Now I may be interested in element-wise product, not the matrix product, but element-wise product of two matrices. So I will, if I use simple star, this will do an element-wise product. So remember, for matrix multiplication, you use the function dot, but for element-wise multiplication, you simply use the star, the ordinary symbol for matrix multiplication. Next, how do we concatenate? I may have two different matrices and I may want to concatenate them to achieve something. This is how I do matrix concatenation. An important point, how do I check now what is the shape of my matrix? Simple way is dot shape. This will tell me the shape. Like let's say the B, the shape is 3 comma 2 or 3 cross 2. For A, the shape was 2 cross 3, but when I do A dot T, A transpose, and the shape is 3 cross 2. So in this way, I can define my, I can get to know what is the shape of my matrix. Now, I want to concatenate two matrices. So A transpose is a matrix of size 3 comma 2 and B is a matrix of size 3 comma 2 as well. I want to concatenate them along, let's say I want to concatenate them like this, horizontally. So A and B, I'm concatenating them along the axis 1. So remember what is axis 1? So this is my axis 0 and this is my axis 1. So along the axis 1 they are concatenated, they are just joined. Now I want to concatenate them one on top of the other, then this is my axis 0. So that's how along this axis 0 they get concatenated and I get the matrix D, which is this. Now the next thing is If I have multiple vectors, let's say A is a vector of 1, comma 1, comma 1, comma 1, B is a vector like this. So see here another way of defining an array or a vector in Numpy. Now I want to concatenate them to form a matrix. I can use hstack to stack them horizontally. It's like this. And I can use vstack to stack them vertically, one on top of the other. So this is what I got with hstack, horizontal stacking. This is what I get with vertical stacking. So this was something about NumPy. Apart from this, NumPy has got many uh, functions like exponential, logarithmic function, power function. Basically, you want to raise something to power of something, power 3, power 4, something. So, square root function. All these functions are also available in NumPy, but I would like that you go to NumPy documentation, go to Google, do a search. How do I take exponent using NumPy? These are very simple things, and I hope you will find it very easily. Thank you.